Hey everyone, welcome back to another LeetCode problem solving video. Today we are looking at a fundamental array problem, finding common elements between two lists while preserving their specific order. Imagine you have a master list called order and a list of your close buddies called friends. You want to filter out everyone from the master list who isn't your friend, keeping list the exact sequence intact. This is awesome problem for beginners because it perfectly demonstrates how a brute force nested loop approach operates. Let's break down the strategy first and then we will look at the code line by line. Our strategy here is very straightforward. It's a brute force matchmaking process. We are going to take the very first element from our order array. Then we will look through the entire friends array one element at a time to see if that number exists there. If we find a match, we instantly lock it into our results list. If we don't find a match, we move to the second element in our order array and scan the entire friends array all over again. Because we scan the second array completely for every single element of the first array, we call this a nested loop approach. Let's see how this looks in C++, explaining the logic block by block. To kick things off, we need a place to collect our matching numbers. We initialize an empty integer vector called res right after we set up our outer for loop using index I to glide through the order vector from start to finish. So let's do that. So first of all, we will create the vector of integer data type, name resultant. Then we will start a loop with int I equals to 0 up to I less than the size of the array, and then increment the I. Now for every single element chosen by our outer loop, we need to scan our second list. So we create a nested inner for loop using index j that loops through every single element inside the friends vector. So let's do that. So for int j equals to 0, j less than friends dot size j plus plus. Okay. Inside this inner loop, we do our comparison check. We ask, is the current element from our order list, order I, exactly equal to the element we are currently looking or add in the friends list, friends of I. Okay, so let's check that. So we will use if condition. If order of I equals friends of j. If that condition evaluates to true, it means we found a common element. We take that value from order I and push it straight into our resultant vector. Once both loops finishes running all their iterations, we simply return our populated resultant vector. So let's do that. If the condition met, we will push it. And then after we will return it. Okay. Let's bring this to a life with a quick dry run. Let's say order equals to 2, 4 and friend equals to 4, 1. Round 1, I equals to 0. We start with I equals to 0. Order of 0 is 2. Now the inner loop kicks off. At j equals to 0, friend of 0 is 4. Does 2 equals 4? No. At j equals to 1, friends of I is 1. Does 2 equals to 1? No. The inner loop ends. Nothing is added to resultant. Now round 2, I equals to 1. Now I increments to 1. Order of 1 is 4. The inner loop restarts from scratch. At j equals to 0, friends of 0 is 4. Does 4 equals to 4? Yes, it's match. We push 4 into our resultant vector. At j equals to 1, friends of I is 1. Does 4 equals to 1? No. The inner loop ends. The outer loop ends and our function returns 4. So let's check whether our code is working properly or not. So first of all, let us run it so that we can cure our syntax errors before submitting. Okay, it is properly working while running. Let's submit it. Okay, it's working properly. Now let's discuss about time complexity. So the time complexity, because we have an inner loop running completely for every single turn of the outer loop, we are performing a multiplication of work. If the size of order is n and the size of friends is m, our total time complexity comes out to order of n cross m. If both arrays are size of n, this is a quadratic order of n square runtime. And space complexity, aside from the vector used to return our final answer, we aren't using any extra arrays or data structures. We are only processing data with simple loop variables. Therefore, our auxiliary space complexity is highly optimized. That is order of 1, which is a constant space. And that is how you implement a nested loop common element search. While this order of n cross m brute force works perfectly for small inputs, in a real interview you could optimize this down to order of n plus m time using a hash set. Let me know in the comments if you want to see that optimized version. If this breakdown helped you see exactly how nested loops interact, smash that like button, subscribe to the channel for more clear code scripts, and keep grinding those problems. I will see you in the next video. Thank you.